So let's begin. So I'm Cyril Gambini. I'm a CLA since 2015, and I'm a CTA since 2016. This is a presentation I made for a LabVIEW user group here in Quebec. It was in French, so I translated it so I can present it in English today. And this presentation was supposed to be presented at VIWeek, but VIWeek being cancelled, so I'm giving it here today. I'm gonna just jump on a slide about NSR technologies with my current employer, and I will let maybe Vincent talk rapidly about the company.
So a quick chat. Basically, NeoSoft Technology is a Silver Alliance partner here in Montreal and Quebec City since 2007. We've been in business since 2000, and we have our full range of CLA, CLT, CLD, CTA, CVI certified engineers as well as instructor as well. And we're an ISO 9001 certified company. And then it goes with the typical alliance partner where we have skills all across the NI product line, going from a compact DAC to just a CompactRIO, PXI, and everything. So without further ado, I'll let Cyril take it away. And Cyril is our technical director since, I guess, 2017 or 18. And I mean, he's been there. He's been in the test and measurement business for the past 14 years, and has worked on several different applications in all sizes.
Thank you, Vincent. So I will move on and continue with the main topic here. So here's a small summary of what we'll see in the presentation. First, we'll give context, then make a quick comparison between every FPGA bitfile code that can perform LabVIEW. And then I will show how we can use LabVIEW Advanced Session to address bitfiles which have different prototypes inside the same application. And I will show the usage of LabVIEW Advanced Session within a VeriStand custom device. State of the art for people already programming. I guess it jumped. So sorry. Okay, context. This context is we've got a request from a customer. Wanted to create a custom device in VeriStand, but his main idea was to call FPGA bitfiles with different IOs, so different prototypes, just to handle the specific options that each C-series module he had can offer. So I can show you a quick presentation of how it looks. So for those who are not familiar with VeriStand, I will not detail what is a custom device. Just understand that here VeriStand has been used to address several targets and deploy codes on several targets. Of nothing related to real-time system here. It just is the ease of configuration of VeriStand that enable us to do such application. And here's need was to configure what we call a high-speed acquisition system. And so we've got several targets that we can address, and with different configurations, so several C-series modules that you can choose from list. And some of these modules do not have specific options. So as you can see here, you can choose a stream, make some acquisition setting, outward scaling, and debug options. But some of the modules they want to use have options like this one, like the 9237. We can choose several excitations in there. choose for algorithm compilation and so on. So from within the same custom device, the same application, we have to launch different bitfile, and different bitfile have different prototypes, so we can set the different option for each module used within the configuration. And so I'll go back to the state of the art, let's say, and see how we can just call bitfiles and LabVIEW. You've got mainly two different ways to call a bitfile in LabVIEW: just a static linking, which is a specific VI call, bitfile call, and you set it all at any time. And you can only launch a bitfile that is identified within the OpenVI specification here. You also have dynamic linking. You can choose bitfile from a path, actually, so you can dynamically change a path to address a specific bitfile, but it must be set to use a specific type def. Here, type def is somehow a bitfile prototype. It just fixes IOs and DMAs that you are using within the bitfile, and it will be used to expose the IOs through property nodes and invoke nodes. So here the problem with that is still, what are the possibilities to call different bitfiles that may have different prototypes within the same application? So here I made a quick slide just to illustrate the problems that we have if we want to call bitfile with different prototypes here. So with static linking, if you have to handle several configurations, you may end with a case structure like this, and as soon as you have a different prototype within your bitfile, you will have a problem here when trying to wire the type def to the tunnel. LabVIEW will refuse it because the type def are not equivalent, so one of the wire may break. So actually, the first one will work, but all the following configuration or following type def will break. Also, with dynamic linking, you can do something like this. It's really a bad idea. I will show you some more examples in detail just right after in the demo. But this may work if the prototypes are equivalent, but you may not know what is really the type defs that will be applied here when running the code dynamic bitfile here. Actually, we've got hints here because of the coercion dot, but you've got some things that are running at any time, but is it bitfile 1 or is it bitfile 2? There's always a dot. So maybe it's better to show you different configurations that we may have, that we may face such applications here. So I made here a quick demo VIs. I've got a CompactRIO that's linked to my computer here. Just I would just emulate the communication right here. So I've got a dynamic open set here. It just set on a bitfile, and I will just run the FPGA and I uncheck the dynamic mode here. So it's standard static code, and just to show you, bitfiles are pretty simple. Version 1 compared to the codes on the FPGA are pretty dumb and very equivalent. Here's configuration 2. So I just changed the prototype. Only the DMA have the same name, which we'll see further in the further demonstrations that it's made on purpose. So just here, the names of the IO register are different. Code is equivalent. So if I try, as I just shown to the PowerPoint, if I try to set a configuration and just use a case structure to iterate through one or the other configuration or other bit file, I will have a problem here because the two terminals are of different types, and FPGA types is set into the reference. So what you may end with is using static calls with the upcast function. It works, definitely it works, but you have to upcast each time the FPGA reference. It will help you for the tunnel passing, but then you will have to handle the configuration everywhere, cast the whole FPGA reference into the bit file reference that you try to address. So here I've got the bit file reference for configuration number 1, here for configuration number 2, and I end up using the standard IO register, but still addressed statically. I cannot choose the name of the inputs I want to address. It's just a static choice that I've got, and it's coming from the type def here. And as soon as finished with that, I need to upcast again the reference to go out of the case structure. So it definitely works. If I run this, it will deploy, and I see there's a counter. It's counting. It works, but it's kind of painful. I must upcast everything, recast. I need to recast the whole FPGA reference to address my input and outputs. So definitely works, but a little bit heavy into the code. Then you've got the dynamic calls. So here is a thing I've shown in the presentation. I've got my two configuration, and based on the configuration name or number, I will try to choose one reference or the other. Here, because the prototypes are completely different, I've got two coercition dots here. I end up with a generic type def there, and trying to open the dynamic bit file, it doesn't even resolve the type def itself. So I cannot choose any IO register here or DMA or anything. So definitely this kind of configuration is not of any interest. So just that's about it. The next idea here is to use the same method that I've used earlier. So I've got a configuration between configuration 1, configuration 2, just an example. And according to the configuration, I will just open dynamically. Here is a path to my bit file. Open dynamically the VI and give the correct configuration here. Because I will have to pass the type def through the tunnel here. Here we can see, for example, that the type def itself is well resolved. I've got access to my IOs. But as soon as I go through the tunnel, the type defs become more generic, and I've got access to nothing. So outside the case structure, I'm kind of losing the IO access or FIFO access. As soon as I disable this, I can again go back into the configuration resolving and cast the whole reference into the specific reference for the bit file I want to use. And again, I've got static access to my IOs. So from here, I must know what kind of bit file I'm going to be using and what are, and I must be prepared to use a specific type def to address the input and output. And here my code is very specific because I cannot dynamically access my IOs by name, for example. It's just accessing them using the static property node here. So if I run this, definitely it's here configuration 2, so DEF. It works. And if I change to configuration 1, again, it's working. So here, the code is dynamic, but I've got some caveats accessing IOs or FIFOs from anywhere in my code, or at least I must know exactly what is the bit file I'm calling just to access the IOs. So maybe there is something a little bit more clever than just doing this. So, sorry. So we had an idea. What if we create a bit file prototype, which is a super prototype, with all the options I need? At the end, the style def is just giving the name of the IOs and types and so on. So if I can create a bit file that is empty, at least no code inside, just the input and outputs and DMA I may need in my future developments, I may be able to choose dynamically what bit file to load, and I've got a super prototype here, and I may access only the IOs that I want. So we jumped to that solution, and we found out that no, it fails. It's not so much a big idea. It works at edit time, but it doesn't work at runtime. So here, I've made a quick demo about it. Here I've got my super prototype. If I look into it, I've got A, B, C, D, E, F, which are all the IOs that I've got in my configuration 1, configuration 2 bit files, even my DMA here. If I look at VI, it just does nothing. It's just here for a prototype. And I've got no error. I can even try to run it. But when you try to run it, here is what happens. You've got an error. Here it is. Bit file is incompatible with the configuration of the FPGA interface reference wire. Why is that? When you call an FPGA and you try to type it, you must have the exact same prototype, not less, not more. So at the end, it was not so much a good idea to do that. So we end up with something that was not a solution at all, trying to load dynamically bit files and address different prototypes. So I'm going to just look at the Discord forums for a second, just to see if there are any questions. People interacting. Okay, perfect.
Do you know if you're using an IP address in the device URL, performance of DMA will be diminished, even if it's a local device?
You know, if you use an IP address in device, or performance will diminish even if it's a local device. Definitely, I guess yes for the question. So you know, if you use an IP address, it's a CMDR that asking this on the Discord forum. You know, if you use an IP address and device URL, performance of DMA will be diminished, even if it's local device. Maybe there is some kind of abstraction trying to push data over the network. when trying to do this. I never benchmarked it, but I would say I will never do it. Here I've just make some demos, so you've seen that there is an IP address within the real description, but it's just for the ease of the demo. So, okay. So we come up with a solution, or at least we found out, I guess it was at VIWeek 2016, that I was attending a presentation, and they just talked about LabVIEW FPGA Advanced Session, and so I thought that maybe it would be a perfect fit for what my customer wanted to achieve, and so call dynamic bitfile with different prototypes using LabVIEW FPGA Advanced Sessions. Just to let you know, it's available since 2015, and it's not officially maintained by NI. So if you've got problems with the LabVIEW Advanced Sessions, there is a dedicated forum, but that's all the help you can have here. Just send a message on the forum, and maybe they will fix something, or you will have to wait for the next release. So the dedicated forums is on the NI Labs toolkit. I will copy and paste later the link into the Discord channel, so you can access it easily. So even if it's available since 2015, there is a package to use it in 2014. So if you have LabVIEW 2014, you can even use LabVIEW FPGA Advanced Session. And the latest package is for LabVIEW 2019, but usually there is a latency of few months between the LabVIEW release and the official package release of the LabVIEW FPGA Advanced Session. So as you can see on the slide here, the LabVIEW FPGA Advanced Session can be summarized with two VIs, so get resources and open resources. I will show you how to use them. For the rest, here is an example of the code you can do the LabVIEW FPGA Advanced Sessions. The rest of the code is standard LabVIEW FPGA function. So here is an open dynamic bit file. Here it's a standard IO node. So the only two resources that are added to the add-on palette is the get resources by name, or get resources, sorry, and open resource by name. So this is just an extraction of what you can find on the LabVIEW FPGA Advanced Session forum, but here I try to explain it a little bit better. It's just with it you can just call radically different bit files from the same host code. You can just create personalized calculation engine running FPGA. You can create FPGA-based plugins. You can create middlewares if you want to create like some abstraction driver that you can give to your customer, and behind the scene it's a set of bit files that are loaded dynamically and addressed dynamically. And definitely we will see this in the demo, but why can you do all of this? Because accessing the IOs is not more static access. You will be able to access the IOs by name. So you would just give a string. If you want the A input, just give a string with A value to the get resource by name, and you will be able to address it. So the type or the prototype of the bit file will not be anymore used to access the entire bit file, but just to access a specific resource that you want to read or write, or the DMA that you want to read or write. So as I said, only two VIs, and you must use it with a code dynamic bitfile without wiring typedef, and this is very, very important. So you will see that the typedef is a generic typedef, kind of empty when you open the bitfile, and then you will need to use these two VIs to access the resources that are present to your bitfile, and use, for example, the open resource VI to read or write to your bitfile, to the FPGA code. I'm just gonna summarize rapidly what these two functions do, and I will make a quick demo right after. So the get resources returns an array of cluster describing all the resources loaded in the bitfile. So you can see the resource name. You can see what type of resource it is. Is it a register? Is it a DMA? Is it target to host DMA, host to target DMA? And there is the data type, so it's var describing the pointed resource. To be honest, and maybe it's a good question I should ask on the forum, I never found out how this data type could be relevant to me. For most of my code, it always returned 0. So maybe it's here for future use. I don't know. Maybe it's something I should ask on the LabVIEW Advanced Session forum. And here is a quick summary of Zen's demo I will show you. So open resource is to access a particular IO into your bitfile. You will specify which IO you want to address using its name. So you need to give the string, a string just to get a pointer or typedef on the IO you will need to use. And then you will be able to just address input and outputs and DMAs. Okay. To do this, I guess it's better to demo it, but you will need to specifically configure an FPGA resource to isolate a resource you want to use and to rename it. So you will see that we will use that that interface that you may know, and we will have to rename the input we want to address value and the DMA we want to access FIFO. So I guess here it's time for me to do a quick demo. So save and LabVIEW Advanced Sessions. So here's a quick demo. So I still have the choice between my configuration 1 and 2, but here you can see that the specific code is quite reduced because this configuration will only be used to choose the path of the bitfile I will load. So here I will still use open dynamic bitfile reference, but without typedef anymore. So the reference I've got here is an empty reference. If you look at the context help here, so if I hover this wire, so there's kind of nothing inside. And if I want to see what's inside my bitfile, I need to use get resources VI, and it will output that cluster I was talking about just earlier with a resource name, data type, and resource type. And then, based on the configuration, I will be able to access to the IO I need, specifying the name using a string. So even this here is static in my code, but you can have a configuration file coming from an init code somewhere, just loading the string here and dynamically feeding this VI with a dynamic string, and you will be able to access the IO that is described here. So how can I do this? here I must specify the type of I/O I will be addressing. So the best here is to create a ref num on the type def. I will just do it from scratch. Create constant new ref number. On your ref number, you can configure the FPGA reference. You can import bit file. I choose configuration 1, for example. And here it's loading all the IOs, DMA, methods, etc. that are in my specific bit file. Let's imagine now that I want to address the B input. I can delete inputs and outputs inside this window. There is a delete button that I never noticed before, but it's there. So you can actually delete here. I'm pressing sup. So delete the delete button. So I will delete everything and rename B with value. And now I've got a ref number that I can use. Or I can even, these are the one I use for the demo. So here and here the value node just came back to life with the correct color according to the type of the value that I will be reading. Here you can notice that I've chosen to isolate the B input, but I will let the A value here, and I will run it. I've got a value here, so there's no loop, just pulling a value from the FPGA. You'll see that the resources just get populated here. So I've got A, B, C IOs, so registers here, and my DMA, which is a DMA FIFO, target to us FIFO. That's here. And why does it work? Because here the type def is not used to point on the specific input or output. It's just pointing on the type of input output I want to use. So if I go back here, what's useful here is the description is the type of the input. So whatever bit file I use, I would just remove it. Here we will say, yeah, it's configuration 1. You use bit file 1. So yeah, maybe it works. So here, I will just reuse something else, import from bit file. I will take the super prototype, which is the VI with all the input and outputs without code inside, completely different from configuration 1, configuration 2 bit file. So if I load it, I've got everything inside. I just isolate the input I want, delete the others, rename this one with value. As long as the type is correct, it will work. Value wire written, and if I run it, I still have it. If I create breakpoints, if you remember, there is a kind of counter into the FPGA code. I just wait just a little bit just to go over 1. And if I release the breakpoint, it's value 25. Yes, there are some questions.
Yeah, maybe a good question for Michael. If you know the name, you can have a dynamic reference and cast it to a particular name, including type. So what would be the real benefit of the advanced sessions, the FPGA sessions?
Dynamic reference to a particular name. Here's a real benefit. It's just I'm casting for only one IO here, and I'm accessing it dynamically. I'm not accessing it statically through an IO node here. Moreover, if you have to pass that type def through sub-VIs or clusters or whatever, input out tunnels or whatever, as long as the type def is typed or linked to the FPGA prototype, you will have issue with tunnel passing and things like that, as I demonstrated just right before. So in the idea of creating middleware, for example, or dynamically accessing input based on the configuration or something that is not static, it just removes the use or many case structures everywhere. You can just access the input you want. So I hope that I answered the question correctly. If not, do not hesitate to send me another question or to.
He did add, so I don't think it will have any worse performance than the advanced session call.
So maybe it's responding to CMDR. And just to go with remarks that Michal did on the Discord link, the latency or the access to these IOs here, yeah, it's not very high speed, I'd say. So that's why I made this not bench. It's not really a bench here. It's just to give an idea of what happens in terms of timing here. But if I run it again, oops, breakpoint, clear breakpoint. Using the ref here, it just less than 1 millisecond, but obtaining a ref is just always more than 1 millisecond. And I will show you then after in the custom device we made for the customer. We open all the reference we need very soon into the FPGA or into the custom device development, because this takes time. Then using them is not so much an issue. I will talk about that after, but as we are in the performance subject, as long as you have less than 128 of these references, there are almost no caveats about it. If you go over 128 references, you will see that you will have more and more latency into accessing input and outputs. However, usually the type which is here really adapts to the bit file. So into the bit file, if you have a cluster, a kind of big cluster with a specific configuration, etc., it can still be addressed here, and the cluster will be just exposed as it's set in the type def. So you can set several IOs, let's say, at once using the cluster passing method. Okay. Here, moreover, here I've just showed earlier, but I can show it again. In my two configuration, I've got a common code, which is here my DMA. My DMA is the same name, same FIFO here. So here, what is specific in my configuration 1 and configuration 2 bit files? So are the IO registers. But the type def here, it's not typed to any prototype of my FPGA. It's a generic type def. So I can go through the specific parts of my code without any tunnel passing issues, and then access also my FIFOs here, my DMAs, in a completely generic way. So if I look at this type def here, when I want to use a DMA, I will have to do the same thing I did earlier. I just point on the bit file where there is my DMA. DMA is here. I remove all the other inputs, and I rename this one FIFO. And here you will see that there is no error at the end. FIFO can start, or I did not make any code to push data into it. So you've got to believe me, but there is no issue here starting with the DMA. So I can have completely generic part of my code I do not have any more issues due to the type def here. And I can just specify, here's the specific type def that I've got here, and even dynamically access the IOs. That's the main point of using the LabVIEW Advanced Session, is dynamically accessing the IO. If you just use it to access different bit files with different prototype, but only using static access to the IOs, there are different methods. I showed them just right before, but there are some painful actions, just casting, upcasting, downcasting the entire FPGA reference just to access them. So here it's a little bit easier to do a generic code to access the IOs. That's why we use the LabVIEW Advanced Session here. And if I've got to show you the end solution we have for the customer. So the project is not finished yet. So you will have to excuse me about the code. It's not as clean as I wish. But here is all the personalities. We support different targets, different settings everywhere with accelerometer modules. Some modules with strain gauges all have their specific options. And if we look into the code, VIs, because I'm not opening the good library engine, and it's here, FPGA constructor. So here's what I have. I dynamically load a bit file. I don't know until the customer does the setting into the System Explorer of VeriStand. I don't know what configuration you will use, what bit file, how many inputs, and how many options you will have to set. I just open this bit file and use here's the open session. Here is a code I've got, or IOs I've got into my each of my FPGAs. So this is a generic code here, and just accessing the values. And here are an example of a specific input strain gauge module configuration. It's taken from JSON, and I've got one big cluster, but I can access it anyway because of the ref number. So I'll get the ref number here. You see that in the cluster, which is called value, it's an array of 7 items with excitation, etc. And just to make it faster and allow to use the reference later in my code without breaking any prototypes, I just made here kind of a lookup here using a variant. So here it's LabVIEW 2018, so I've got no maps, so still using a lookup to do so. And I'm storing with the name of the IO, the specific reference of this IO. So I only open the IO once, that's all. I don't even have to care about closing the specific reference of the IO. Before Rio 13, it was necessary to close all them one by one. Otherwise, you had some weird behavior. But now you didn't have to close any of them. As soon as you close the main FPGA reference, everything will be closed behind the scene. And you can access it all from my configuration. And if we look into the,
maybe one quick question.
Yeah.
From Maddie J. Wow, that's a lot of targets. How long does that project take to load? And also, how did you get that extra folder on top? Did you create some project provider?
Nope, no project provider here. How much time does it take to load? That's a very good question, but it's VeriStand based, so it takes quite time to load. But actually, within the System Explorer, we only define one configuration. So I've got an action VI that is able to determine which bit file I should use. And then I just send that bit file on the target and open only one bit file. So it doesn't take that much time to load. maybe just a standard 10 or 15 seconds load with VeriStand, but it's not really related to this specific custom device. And then to answer to this specific folder here, it's not new. I don't know when it appears in LabVIEW, but you can do a target folder. So yeah, and you can place them wherever.
Peter, this advanced FPGA stuff sounds really nice, but did you consider wrapping this stuff into LabVIEW classes and use dynamic dispatch?
Sure, we did. But we had an issue with LabVIEW 2018 where the type def or generative def was not really well handled into the private data of the classes, and there was some issues after that. I don't remember very well because we jumped quite fast to the LabVIEW Advanced Session after, but it wasn't working that well. And moreover, you still have that specific access to I/O registers. Here, it seems that we are still accessing the I/Os like statically because I open hole right before the execution begins of the FPGA, and then use the reference to access the values I need. But there is a feature coming where the user could specify different options that we may need to access on the fly. So like an even polling data from the FPGA, we need to access on the fly things, IOs from the FPGA. So here I'm still retrieving from the lookup the specific reference that is pointing on my DMA, and I still use the FIFO read and FIFO read methods to get my data. So it works quite well here. It works for now several months at the customer facility. Still trying to improve things. That's why the code is not as clean as I wish. But here we have configuration with 9049 targets that are running 32 inputs at more than 50 kilosample per second on each input. And I've got no trouble using the FPGA Advanced Session on such configuration. So I'm not talking here about accessing the IOs with a microsecond latency. But at the end, when you've got DMA, it really depends on how you perform or you code your FPGA or what you want to do with it. But using the DMA, all the buffering is down here. I can just massively get my data and treat it and give it to VeriStand just to save data into files and to display to users. And I've got no caveats here using LabVIEW Advanced Sessions.
Maybe a same comment and same situation in terms of the software running for the past 7-8 months. Terry says basically it's unsupported software by NI. Don't feel comfortable telling the customer that this is in their code. At the same time, it's updated every year, so it must be good.
Yeah, that was an issue that we discussed with our customer before implementing it into the solution, and the customer was willing to test it. And we tested it. We are even using TSN within the FPGA code just to timestamp every samples. At the end, when we look into the VeriStand Product Explorer here for the demo, I only have one target, but the customer may have up to 10 targets on the network, each target running this custom device and doing the high-speed acquisition. And with TSN, we are able to phase all the measurement on each target. And we do not have seen any issue doing this using FPGA Advanced Sessions. So here the code is really not related to timestamping things into the FPGA. I know about it, but introducing the FPGA Advanced Session into such precise timestamp or timestamping things coming from the FPGA, we did not notice any issue with the precision of 100 nanoseconds thanks to TSN timestamping. So really, here at the end, it just works for us.
Maybe a quick comment from Piotr. You could use dynamic FPGA references inside classes to make it nice, clean, and still fulfill your needs, and load only particular stuff at runtime.
Yeah, there is always ways to improve. I agree with you. That's definitely true. My customer is not also very out of service. Is not using object-oriented code at all. It does not want to learn about it, and this code is participating to the development. So here's a problem. And then using dynamic dispatch onto VeriStand, into VeriStand code, I guess when you're creating or working on a custom device on VeriStand, you don't want to spend time debugging issues with your dynamic dispatch or things like that. It just coding a debugging custom device can be PITA, like I've seen on the Discord channel. It was just easier to go with traditional LabVIEW and use the abstractions that the LabVIEW Advanced Session gives to achieve some such performance here. So maybe that's it with the demo. I guess I'm running to the end of the presentation. Again, it's reading. So yeah, just the pro and cons at the end. Really, again, it's really helpful when you need to access the FPGA resources by name. Again, if you want just to access different bit files at runtimes or other ways, I've showed them all, or maybe there are some others like Piotr said, using dynamic dispatch, definitely yes, but you are still linked statically to the FPGA prototype that you are loading. So here there is a little bit, it's just a little bit more dynamic to use FPGA Advanced Sessions. Here, no more type def reference to open a bit file. So for tunnel passing or things like that, it just really eases everything. Access performance may decrease if there are too many references open. It really depends if you open them on the fly or if you open them at the initialization of your code and then reuse the reference itself. And based on the forums, I must be honest, I never overpass that 128 number. But if you are not overpassing that number, I did not notice any access performance issues. Above this, for example, if you open 256 references, you may see latencies that will double according to the latencies that you would observe using less than 128 references. Also, if you open more than 128 references, you will see a warning running through your error wire. So it's warning 63186. It's just a warning, and it's just telling you that you've got too many references open. It will still work, but you may notice performance issues. Then the code becomes hard to read. You've seen that there are wires more than before, and it's a lot of wires everywhere. You've got to every IO node is now called value or FIFO. Yeah, which one am I reading? It can be hard to read. And the limited support that NIS offers, there is just that forum. It's supported for several years now, but I don't even know if you can call the support to expose a problem. Just probably just post a message there, and that's all. And also, the installer usually appears in the forum several months after the LabVIEW release. So if you are trying to test that functions with LabVIEW 2019. I guess that just installer was released like maybe 3 or 4 months ago. Same thing for 2018. We had to wait like almost 6 months before it was officially released. So there are always tips and tricks to copy the files from one LabVIEW earlier year to the new LabVIEW that you have on your computer. It will still work, but still not the best option to install.
Is the 128 limitation reference somewhere? Is it an official limitation or?
It's from the forum. Definitely yes. I did not benchmark it, so it's definitely on the forums. The one who spoke about the 128 references is a guy from NI. So I guess he knows about it. And yes, it's actually 127 individual ref name, because one of the ref numbers is a reference of the bit file itself. So that's still a lot of references that you can open. If you have more than 128 inputs or outputs to your FPGA or registers, in my opinion, maybe there is some rework to do, or maybe some cluster to insert in your code, or I don't know. But that's still, I guess, a lot to access your FPGA code.
There seems to be a quick disagreement in terms of being the number of copies of refnum versus individual refnums. That might be something to look into. Okay, maybe afterwards.
Something to dig into. Yeah. Point is that really, if you go over that 127, 28 ref numbers, maybe there is something else to consider, or there are tips and tricks to lower the number of IOs in your FPGA. So I guess I've reached the end of the presentation, so I can stay online to answer to the question on Discord.
Maybe 2 other questions I noted, but not really related to FPGA sessions. One was, is it faster, better to get data from an FPGA via the property nodes as shown as the presentation, or as a queue target to host?
The register, it really depends on what you want to do with your FPGA. If you don't want to lose any data that this FPGA is producing, you will definitely have to put all that into a DMA. If you can just access them point by point, just use registers. There is a latency of a few microseconds using registers. So if the data changes between 2 reads, just don't know about it. There is no buffering there. So if you need to get all the data and do not lose any points that the FPGA may produce, definitely you may have to use a DMA FIFO.
And I think that, well, the other question seems to be, do you have some resources for performance comparison between direct access to a front panel element and equivalent size FIFO? And there was another answer given, which is, it seems that it has, if it's higher than 64 bytes, it has lower latency than FIFOs. I guess that was just a comment or answer.
But again, it really depends of the on the code you are producing. It's really in terms of not losing any data. Just using a register, you just override data from one loop to another, and you just read it. And that's also depends of the reading code. So in your RT, or it really depends on how your application is coded there. Personally, if I've got to get data and not losing any points, I always use DMAs, and I just pull my DMA regularly and work on it. Yeah, so I guess at the end of the presentation, I will just close the live event. I'm staying on the Discord channel for
I guess there was a
few
lounge
minutes after.
request from my call.
Okay.
I'm not sure where you go in that lounge.
I will. Okay, I will be in the lounge. I will stay there, and we can even discuss after that. So yes, I will manage it on my Discord app. That's okay.
Mathieu says thank you.
You're welcome. So I will share the video after on LabVIEW wiki, and if you have any question about this or want to discuss any points about LabVIEW FPGA Advanced Sessions, so feel free to contact me in the Discord channels or send me an email. So thank you, everyone. And I hope to see you maybe next year at the VIWeek. Who knows? Bye-bye.
Thank you.